So we're going to start 5-8, and I just picked up my pack of papers that I'm going to write on. It feels so thick. I had planned on 4 parts. Let's hope I can do it. In section 5-8, we're going to use factoring to solve problems that have equal signs, or to use factoring to solve equations. And the theory behind this, essentially, this whole section is there's a property called the zero product property. It essentially says if you multiply 2 or more factors or 2 or more numbers, the only way you can get 0 is if one of them is 0. So if I multiplied, 2 times 3, clearly that's not going to be 0. But if I multiply 2 times 0, that has to be 0. The only way you can get 0 in a string of multiplications is if at least one of the numbers is 0. That's what the zero factor property says. And we can use the zero factor property to solve equations. And I wrote a couple examples that we'll maybe run through, at least one example here up at the beginning, and then we'll do some more examples later on. So the first 21 problems kind of have this feel. It says solve using the zero product property, and I think the instructions in the homework just say solve. Maybe they say solve the equation. An equation being a problem with an equal sign. Problems with equal signs get numerical answers, and the nice thing about equations is I can always check my answers to make sure I'm right. And there are multiple steps to these problems as they get more complicated. My goal is always to have the left side factored. If I can make the left side, it could be the right side. But one side factors, usually the left side. And the right side 0. If I can get an equation to be in that form, one side factored, the other side 0, then I can use the zero factor property by just taking each of the factors and separately setting them equal to 0. We're going to have multiple steps to solve some problems that aren't set up in the form left side factored, right side 0. And as we get deeper into the part 2s, part 3s, and part 4s of the video, there's going to be multiple steps that need to be taken because the problem won't be written with left side factored, right side 0. But the problem that I wrote for our first example, x minus 2 times x minus 5 equal to 0, that's already in the form. Step 1 for this says set the equation equal to 0. This equation is equal to 0. That step's not going to be necessary. Step 2, make sure the equation is completely factored. It's already completely factored. These steps that I crossed out, I don't need to worry about. Step 3 says take each factor, the factor of x minus 2 and the factor of x minus 5, separately set them equal to 0. This is using the zero factor property. I'm trying to find the numbers I can plug in to make either factor 0, because that's the only way the right side and the left side are going to be the same. The only way I can get the left side to be 0 is if I put a number in for x and make one of the parentheses 0. So my algebra for this, because the right side is 0, the left side is factored, my algebra is just to set the factors equal to 0, do the algebra. In this case, it's adding 2 and adding 5 to both sides. I claim that the answer to the equation x minus 2 times x minus 5 equals 0 is x equal 2 and x equal to 5. I usually write the individual answers separated by a comma, and I write the variable once. I could have written x equal 2, x equal 5 for an answer, or I could have written just 2 comma 5 for an answer without the x's. Those are all equally good ways to write my answer. My general way is this, which is dangerous in that I don't always use x's, and sometimes I forget and I write x for an answer when an answer really should be a y, whereas there, if I choke on the letters, it's not going to technically be wrong. Anyways, if I want to check, I need to take my original problem and whatever answer I'm checking, and I need to go to the original problem change the variables in the original problem to the number I'm checking and make sure I get a true statement. So I changed my x's to 2 to check 2. That gave me 2 minus 2 times 2 minus 5 equals to 0. The 2 minus 2 parentheses was 0. The 2 minus 5 parentheses came out to negative 3. On the left-hand side, 0 times negative 3 is negative 3. So this checks because it leads to 0 equals to 0. Similarly, plugging 5 in for the x's in the original problem, I get 5 minus 2 times 5 minus 5 equals to 0. The 5 minus 2 is 3. The 5 minus 5 is 0. Here's where the zero factor property comes in. The only way, if I multiply two numbers, that you can get 0 is if one or the other is 0 or both is 0. And on the left-hand side now, if I multiply 3 times 0, I get 0. So the left-hand side and the right-hand side wind up equaling each other, so I know my answer is right. Each of the problems for the first 21 problems, we're going to use this zero factor property immediately. Each of the problems is set up to have the right side 0, so my goal is to have one side 0. That would be step 1. If I don't have a 0, I need to get one side to be 0, usually the right side. That's done for this problem, so I'm not going to worry about it. Step 2, I need to have the problem completely factored. That's done for this one. And then step 3, I'm going to set the factors equal to 0. And I could usually sight solve, but I'll show you the algebra here. That gives me my answer. And then step 4, it's optional, but I can calculator check so fast that I'm going to check a lot. First by hand and then just mindlessly calculator check. So for number 2, to get the answers that I'm looking for, I'm going to set x plus 3 equal to 0 and x minus 5 equal to 0. The x plus 3, I'm going to get my answer of negative 3 by minusing 3 from both sides. The x minus 5, I'm going to get my answer of positive 5 by adding 5 to both sides. I'm going to write my answer, and my standard way is to write the variable once, followed by an equal sign, and then the individual answers I'm going to separate with a comma. Now I'm going to check. I can't check them both simultaneously. I need to check independently the numbers. Negative 3 for me is the harder one to check. Let me check it first. Make sure that negative 3 plus 3 times negative 3 minus 5 actually equals 0. The first parentheses, the numbers are opposite, so they combine to be 0. The second parentheses, both the numbers are negative. I'll add them and keep them negative. And then 0 times negative 8 is 0. So the x equal to negative 3 checks. And now I'll check the x equal to 5. I'll put a 5 in for both x's and see if 5 plus 3 times 5 minus 5 equals 0. This would give me 8 times 0 equals 0, and there's that zero product property. The only way a product of two numbers can be 0 is if at least one of them is 0. Both numbers check. Maybe I won't get checked so much, it'll trim the video down quite a bit if I don't check everything, but I'll check more than I normally check. For number 4, the right side is 0, the left side is completely factored. I go on to set the insides of the parentheses or set the factors equal to 0. The factor of x minus 9, to get the solution from it, I'd add 9 to both sides. The factor of x minus 10, I'd add 10 to both sides to get the solution from it. Those you probably can get by inspection. I probably, if I was writing a test key, I wouldn't even show any work. I just would have written down the answers. I'm not going to check that. I'll check occasionally, but not everything. I'll check 7 or 8 because you get a fraction answer. So My hopes are to have one of the sides 0, normally it's the right side. The other side factored, normally it's the left side. And if I get to that, then I can set the factors equal to 0. If the right side isn't 0, I shouldn't set the factors equal to 0. And if I don't have the problem factored, I shouldn't set the factors equal to 0. I'm having issues with the focus today. Good enough. So I'm just going to set the factors equal to 0 and do the 2 steps of algebra to solve these. And I'm not going to check this because it's a very nice solution. The next one I'm going to check though. am checking because I have the answers printed out just to avoid making a mistake. In chapter 4 I didn't check a lot, and now I'm freaked out that I might have mistakes that I'm going to have to re-record the videos if I wasn't being so careless. So for the 2x minus 12 factor, I add 12 and divide by 2 and get an answer of 6. For the 3x plus 15 factor, I minus 15 and get 3x equals minus 15. I divide by 3, divide by 3, and get x equal negative 5. I'm banking that I didn't make a math error, but I could confirm that I didn't make a math error if I took the time to check. From probably now on, checking is going to mean calculator checking. Let me do 8. 8, the right side is 0, the left side is factored. I can go straight into, in problem 8, taking the contents of my parentheses and setting them equal to 0. Or taking the individual factors and setting them equal to 0. But I get double fractions, which would be a nuisance to non-calculator check. But I'm going to calculator check. The 5x plus 4 set equal to 0. I'll minus 4 from both sides and get 5x equals negative 4. And then I'll divide both sides by 5 and get x equal negative 4/5. The 2x minus 3, I'll add 3 to both sides and get 2x equals to 3. And then I'll divide by 2, divide by 2, and get x equals to 3/2. My go-to answer writing is put the variable followed by an equals, put the individual numbers to the right of that equal sign, separated by a comma. Calculator check now, because fractions are intimidating, but we can get fraction answers. I'm going to calculator check x equal negative 4/5 by going 5 times negative 4/5 times 2 times negative 4/5 minus 3. And the only way this is right is if when I enter this I get 0. If I don't get 0, I've made an algebra error. So I might make a calculator error, but let me try this. 5 times fraction negative 4/5. Whoops, I forgot the plus 4 in this one. Should be 5 times negative 4/5 plus 4. Forgot the plus 4, so freaked out by the fraction. That's the end of the first parentheses. Second parentheses, 2 times fraction negative 4 over negative 4 over 5 minus 3. When I hit equals, if I don't get 0, it either means I made a math error or a calculator error, and I'll have to figure out which. If I get 0, it works. So I know that negative 4/5 is a solution because it checks. And now I'll do the same for 3/2. For 3/2, I'll see if 5 times 3/2 plus 4, changing that x to 3/2, times 2 times 3/2 minus 3, see if that results to 0. And it will if I don't make an error here. So parentheses, 5 times fraction 3/2 plus 4, close out my parentheses. Second parentheses, 2 times fraction 3/2 minus 3. Beautiful. Both of these check just fine. So my answer to problem 8 is negative 4/5 and positive 3/2. 10 is way more interesting than 9 because 10 has this common factor with an x. I'm going to make a comment here that's going to be 100% true. Common factors with an x, or GCFs with an x, give a solution of 0. This problem, number 10, has a common factor with an x. It's going to get a solution of 0. To solve number 10, I'm going to go 3x equals 0, x minus 4 equal to 0, and x plus 5 equal to 0. The 3x equal to 0, I'll divide by 3, divide by 3. On the left-hand side, the 3's cancel, I'm left with the x. And on the right-hand side, I have a fraction with 0 in the numerator. Fractions with 0 in the numerator are equal to 0. It's fractions with 0 in the denominator that are undefined. The other factors give me an answer of positive 4 and negative 5. I claim the answers to problem 10 are 0, 4, and negative 5. Let me show you that the 0 checks. To check the 0, I'd go 3 times 0 times 0 minus 4 times 0 plus 5, changing each of the x's in problem 10 to 0. So 3 times 0 times 0 minus 4 times 0 plus 5, and you get 0 when you plug it in, and because the right side is already 0, I know that checks. The 4 and the negative 5 will also check. I'll move on to 12. In 12, I'm going to go 4x equal to 0, 2x minus 10 equal to 0, 3x plus 15 equal to 0. The 4x is a common factor with an x. It's going to give a solution of 0. To get the solution algebraically, I divide both sides by 4. The 2x minus 10 is going to give a solution of positive 5. I'd add 10 to both sides and then divide both sides by 2. And the 3x plus 15 is going to get a solution or give a solution of negative 5. I'll subtract 15 and get 3x equals negative 15, and then divide by 3 and get x equal to negative 5. For number 12, when I go to write my answer, I can write x equal to 0, comma, x equal to 5, comma, x equal to negative 5, or x equal to 0, comma, 5, comma, negative 5. Anytime we get the same number or the opposites of some number as an answer, there's another way to write my answer using a plus or minus symbol. These two have the same meaning. They mean the answers are 0, 5, and negative 5. A plus or minus symbol in front of a number means the positive and negative version of that. That I'm not going to check. And I'm not going to do every problem on the next page because, again, I'm at 19 minutes and I have 4 more to do, so maybe 5 more minutes for part 1, and then we're going to have 2, 3, and 4. So let me do 16. For 16, I have it's set equal to 0. It's factored. I can just set the factors equal to 0. The first factor is x. When I set it equal to 0, it gives me an answer that doesn't need any algebra. It's just there. I'm done, but it's a solution. Common factors with an x give a solution of 0, and I have a common factor with an x there, so I'm going to get a solution of 0. So the first factor gives a solution of 0. The 7x minus 10, to get the solution from it, I'm going to add 10 to both sides and divide both sides by 7. That gives an answer of x equals 10 over 7. I'm going to put that in my answer next to the 0. The 3x minus 16 gives an answer of 16 over 3. All of these will check. I'll just write the answer down just to save time because I know this is going to be a 4-parter. And the checking, you can mindlessly press buttons if you want to. Next trick, common factors that don't have an x don't give a solution. That 17, 18, 19, and 20 have a common factor. Common factors that are a constant, that would be a number without a letter. And I'll show you that the common factor doesn't check. Let's just do 18. 18 is factored and set equal to 0. I'll go 4 equal to 0, x minus 3 equal to 0, and x plus 5 equal to 0. The 4 equal to 0 is not going to give me a solution. I'll show you in a second that 4 doesn't check. The x minus 3, you'd have to add 3 to both sides. The x plus 5, you'd have to subtract 5 from both sides. That you should do in your head if you can. You don't need to be showing all the algebra that I'm showing. Let me show you that 4 doesn't work. If I plugged 4 in for x, because I thought that common factor should give a solution of 4, I can plug it in to the original problem, and I'll get what happens when I have a bad solution. If I did 4 times 4 minus 3 times 4 plus 5, that's going to give me 36 equals 0. That's not good. Even if you thought negative 4 was the solution, you thought you had to minus 4 from both sides, if I change the 4's to negative 4's, I'd still get garbage. This time I get 28 equal to 0. The important thing here is common factors without an x, you can just ignore. They don't give a solution. In problem 20, it's factored and set equal to 0. So I'm going to set 11 equal to 0. That's a common factor without an x. It doesn't give a solution. I can set the 4x minus 1 equal to 0. If you could just look at that and say the answer is 1/4, that's better than doing what I'm about to do. Add 1 to both sides and divide both sides by 4. Similarly, if you could know that you get an answer of 5/3 from the second parentheses because you can solve that in your head, more power to you. That's what I would do. But if you need to do the steps, do the steps. The steps help you get partial credit on tests if you make mistakes. So for number 20, my answer is going to be x equal to positive 1/4 and positive 5/3. There's one more problem, but it's an odd problem, so if you want to do it, give it a go. I'm going to pause the video and we're going to start our part 2, which is going to have one more step of work. I'll have to do the factoring. It won't be done for me.